Okay, in this question it says to calculate the value of x, so we want this side here. You'll notice that we've got these two sides already given, so we can use Pythagoras. Okay, so using Pythagoras, we've got x squared, the longest side, is equal to the square of the longest side is equal to the square of both shorter sides added together. So 6.7 squared plus 8.4 squared. So I can have x squared equals, use my calculator, (115.45). So x will equal square root of 115.45. And I get 10.7447 in my calculator. But I'm just going to write one decimal place because the information in the question is the one decimal place as well. Part B, it says calculate the size of angle y. Okay, so this involves trigonometry. Alright, and what I do, I go to my triangle and I first of all label my sides. I call this side my h, my hypotenuse, because it's the longest side, is opposite the right angle. This side here I call O, because it's opposite the angle I'm looking for. And then the adjacent then is the angle that is the side that's, the adjacent is the side that's next to the angle on the right angle. Okay, so when I want angle y, I'm going to now use two sides that are useful. Now the sides that are useful here, obviously the ones they've given me. So that will be O and A. So I write down here O, A. Now I need to decide whether I use sine, cos or tan. Of course, a good way of remembering that is using the mnemonic SOHCAHTOA. If you remember that, SOHCAHTOA, you can see then the one with O and A in is tan. So we'll have tan angle y equals opposite over adjacent. Okay, so the opposite divided by the adjacent. So we'll have 8.4 divided by 6.7. Okay, so to get y, now I need to sort of think about taking tan over the other side. So I do tan to the minus 1 of that fraction on my calculator. To get tan to the minus 1, you press shift tan 8.4 divided by 6.7 and you get the angle out straight away, 51.4 degrees. Okay, second problem. We've got two triangles here, and it says given that BE is 7.2, DE is 1.3, AC is 12.8, calculate the size of ACD. So when it says ACD, the roof above obviously is, we're talking about angle. ACD is this angle here. Now usually when they have two triangles next to each other, you need to use both triangles, work something out on one of the triangles and it will help you with the other triangle. So given that we want this angle here, I'm going to work on this triangle first. Work with this triangle first. I think what would be useful in this triangle, if I can work out this length AD, then I can use that result to find the angle. If we just focus on this large triangle, we've got angle, we've got sides, so we can use trigonometry. H for hypotenuse, O opposite the angle and adjacent here. Now I want to work out O, okay, which is this larger side of this triangle. So O is what I want to work out. I'm going to use A as well because A is the side that they've given me. So OA, again, SOHCAHTOA, OA, tan again. So I have tan, the angle 55 equals opposite over adjacent, so opposite over the adjacent, which is 7.2. Now here I want to work out opposite, so to get opposite in zone I need to take the 7.2 over the other side. Because I'm dividing by 7.2 and I take it over, I'm going to multiply. So 7.2 times tan 55, and I get 10.71, which is O. Of course O is this side here, so I can say that AE is 10.71. Now what's good about this is, now that I know AE, I can actually now work out AD. Okay, so AD would be the result of using AE and subtracting this small amount here. So AD would equal 10.71, take away 1.3. So I could use my calculator, or you could work it out. 9.41. So I know this side here is 9.41. Okay, so we've done the first stage. Now let's work out this angle. Now let's focus on this smaller triangle. If we use trigonometry on this side of the triangle, this triangle here, again you've got a hypotenuse here, and because it's this angle we want, we can call this side the opposite. Now in this instance, it's O and H. Those are the sides we know, so we're going to use O and H. OH. Okay? So O and H, of course, would be sine. So you have sine equals sine of the angle. So the angle is ACD, will equal the opposite, which is 9.41 over the hypotenuse, which is 12.8. So angle ACD will be then the sine to the minus 1 of this fraction, which will equal to 47.3 degrees.